So this is the third video in my series on causal inference, and this one's going to focus on group level causation. So as always, I just need to acknowledge this book called What If by Miguel Hernan and James Robbins, which was most of the ideas that I'm talking about in these lectures come from this book, and the order in which I'm presenting them is also pretty consistent with this book. So as I mentioned before, there's like a kind of hierarchy of causal inference, and we're still kind of in the potential outcomes framework realm of causal inference. And just a review of what we talked about last time, at an individual level, causation is best kind of visualized in this sequence of events here. We're just focusing on the top for right now. We have timeline 1, where this individual got the vaccine and didn't get the outcome. If we were to go back in time and let that entire course of events play out, with the only change being that this person no longer got the vaccine, if we see that their outcome status is different between the two timelines, we can attribute any difference in the flu to the fact that there is a difference in vaccine status, basically. And this would represent causation at the individual level. So why this is so important is just that why this is kind of the be-all and end-all of causal inference is that within these two timelines, the only real difference is that the individual was vaccinated in timeline 1, but not in timeline 2. But so much is held constant, like all biological factors, geography, and calendar time, that we can pretty much attribute any difference in the flu to the fact that the person was vaccinated in one situation and not in the other. But most of what we actually do in epidemiology is at the group level. So we're pretty much ideally, like I said in the last lecture, if we could have a treated and untreated group that consisted of just clones of the same individual, that would be great, because then we'd control for all biological factors. But that's not possible. So generally we try and create a treated and untreated group that are as close to being like clones of each other basically as possible. We can do that by matching on factors or just controlling for it analytically, just taking action to make sure that like the distribution of confounders in the two group is equal basically. So if we follow this group of treated and untreated individuals, we can look at the distribution of the outcome status in the two groups. You can just kind of see that with the bottom one in the untreated group, there's 4 people coughing, while in the treated group there's 2 people coughing. So that's the basis of how we would draw inference as far as like whether the difference in the distribution of the outcome in the two groups, that being it's more common in the untreated group, we try and say that that's because they didn't get vaccinated. And to be able to say that, we need to have these two groups as similar as possible. Ideally, the only difference between the two groups is the vaccination status. But in reality, these two groups are going to differ in a lot of ways if we're not assigning them, like in an observational situation where these individuals assign themselves to go get the vaccine or not. Individuals who choose to get the vaccine will likely differ from those who choose not to. And then it becomes very difficult to say if any difference in the outcome in the treated and untreated group is due to the vaccine or not. So now we're going back into the hypothetical realm, back into the potential outcomes realm, where we're going to be pretty much talking about how we can apply that individual level causation that we talked about before to the group level. So we are now looking at average causal effects. So basically the left-hand side of this difference, so we have average causal effects equals proportion sick had everyone being treated minus proportion sick had no one being treated. I find it helpful to add visuals to this. So let's just start with this table here where we have 4 individuals, and this pale blue part is the observed or factual situation, where the first 2 individuals were treated, they got the vaccine, and they didn't get the outcome. And the other 2 individuals were untreated, and they got sick. Each of these individuals has a hypothetical counterfactual state on the right, the pale orange, where that's pretty much what would have happened had they received the other treatment, basically. And even though we're not observing it, this framework relies on the assumption that this exists out there and is like this constant situation that even though we're not observing it, it would have happened. Like had individual 1 not received the vaccine, they would have gotten sick. But we can't observe that, but just again, like I said, we're back in the hypothetical realm where basically if you take that as a given, we can move forward basically. So what we can do with this is you can see that this like pale blue part and the pale orange part are both half treated and half untreated. But if we kind of break this table up and switch these two at the bottom, we can end up with these two tables. The one on the left is the situation where everyone is treated, and the one on the right is the situation where no one is treated. And each is made up of two real pale blue observed situations and two hypothetical counterfactual situations, the pale orange. And now you can see, like I was talking about before, where I'm saying things like the proportion of the sick people had everyone being treated. That's where we're getting this basically, this everyone being treated on the left in this table and no one being treated on the right here. Yeah, so you probably can see where I'm going with this, but if we go through some calculations, it'll kind of solidify that. So here, if we just focus on the table where everyone's treated, and we figure out the proportion of those who would have gotten the outcome had everyone being treated, we can see that individual 4 got sick, but no one else did. So the probability of the outcome, if everyone in our population of 4 people had been treated, is 1/4. We can do the same with the untreated group, where we can see that individual 2 didn't get the outcome, but everyone else did. So the probability of the outcome had no one being treated is 3/4. And now we can find the average causal effect. So the causal effect would be 1/4 minus 3/4. That comes to negative 2/4, which breaks down into negative 1/2. But something that is worth noting is that it is an average causal effect, and the consequence of that is that we're going to start with notation. So here in this observed group, the pale blue, we call A the exposure and Y the outcome, same as before. With the unobserved counterfactual stuff, we're generally putting whatever the parameter is, A or Y, in brackets. And here, like this individual 1 has they were vaccinated in this pale blue observed state, so they get a 1 in that A cell, and they get a 0 in the Y cell because they did not get the flu. So if we carry that through, we can pretty much take this table we had before and convert it all into like codable data, and that's what that looks like basically. And same as before, we can this table where on the left we have all treated and on the right we have all untreated. That can also be resolved into code basically. And now we have like our notation that we kind of started talking about before in the last lecture. Where on the left, the notation that describes this table is the probability of, so the situation where everyone is treated, so Y subscript A equals 1, the probability of that ends up being 1/4 because there's 1 individual with the outcome and 4 individuals. And on the right, Y subscript A equals 0 equals 1 ends up being 3/4. Yeah. And so this is just the same slide as before. So as far as figuring out whether there's a causal effect is pretty much seeing if the proportion of people that get sick had everyone being treated is different than the proportion of people that get sick had no one being treated. And we can see that that's true here on the left. The probability of the outcome in the all-treated situation is 1/4, and more people got sick in the world had no one been treated. And that's group-level causation. And just looking back at individual-level causation, we're looking at one person. We look at their observed state. Again, this person got the vaccine, didn't get sick. Their counterfactual situation is not getting the vaccine and getting sick. And 0 and 1 aren't equal, so that's a causal relationship at the individual level, and this is a lack of 1 where it's 0 in both cases. And you can see that this is what I was going for before when I was starting to talk about the average causal effect. As you can see that there's a causal effect among some but not among others. So With individual 1 here, their counterfactual and observed situation is different, so there's a causal effect in that individual. But in some of the other ones, like in individual 2 and 4, there's not a causal effect. So that's why even though some of the individuals had an individual level causal effect and some didn't, there can still be an average level causal effect. And as far as kind of driving that home, I can just go through the calculations, if you bear with me, where basically we can show that this group level causal effect can be found from actually taking an average of these individual level causal effects. So to do that, we would have to basically take everyone's outcome status when they're treated and subtract their outcome status when they were untreated. So this individual, when they were treated, they had an outcome of 0 because they did not get sick, and when they were untreated, they had an outcome of 1 because they did get sick. So the individual level effect here is -1, and if we do that for each individual and add them up, we get -2. And there's 4 individuals, so if you divide by 4, you get an average causal effect of -1/2, and that's what we got before. So yeah, that's causal inference at the group level, and I hope that was helpful.